Hello guys, today in this video we are going to study about the structure of atom. So every substance in the universe is made of atom. Atom consists of central part, okay, this one. This central part is called as a nucleus. And the diameter of atom is 10 to the power minus 10 meter. The diameter of the nucleus is 10 to the power minus 14 meter, and the diameter of electron is 10 to the power minus 15 meter. Okay, now we will see each and every part: electrons, protons, and neutrons. In the nucleus, we have the proton and the neutron. Okay, atom consists of electron, proton, neutron. Yes, and in an atom we have this nucleus, and in this nucleus we have the proton and the neutron. Electrons, this revolves around the nucleus. This is the nucleus and the electron will revolve around this. Okay, but this electron revolves around the nucleus by the electrostatic force of attraction in between them, and electrostatic force of attraction acts against the centrifugal force to keep the electrons in their orbit. Now, the circumference of this orbit is can be calculated by using formula 2 pi r. Okay, 2 pi r. Now we will see the comparison between electron, proton, and neutron. Now this is the comparison of the proton, neutron, and electron. The proton has a positive charge and the neutron is have zero charge or neutral charge, or the neutron is a chargeless. Electron has a negative charge. The charge on the proton is 1.602 into 10 to the power minus 19 coulomb, and the charge on the neutron is 0. Okay, no charge is there, that's why. And the charge on electron is minus 1.602 into 10 to the power 19 coulomb. Okay, so this is the just opposite of this proton. The mass of the proton is 1.67 into 10 to the power minus 27 kg, which is 1840 times of the electrons. And the mass of electron is how much? 9.11 into 10 to the power minus 31 kg. The mass of neutron is equal to mass of proton, and that is same, 1.67 into 10 to the power minus 27 kg approximately. So proton presents in the nucleus, as I said. Proton presents in the nucleus, as well as this neutron also presents in the nucleus of an atom. But in case of hydrogen, the neutron does not present in the nucleus of atom, only in case of hydrogen. Okay, this is the exception. Electron presents in the outer shell within an atom. Okay, so outer shell, the electron presents in the outer shell. The mass of the proton is taken as a 1 unit and equals the mass of neutron. The mass of proton and the mass of neutron both are equal, okay, equal to each other, and the mass of electron is about 1 by 2000 times the mass of hydrogen atom. Okay, so protons only take part in the nuclear reaction. Neutrons, it exposed to nuclear reaction, and electrons takes parts in both chemical reactions and the nuclear reactions. In an atom, the electron is discovered by the scientist whose name is Thomson. Okay, and the proton is discovered by the Rutherford. Yes, remember this: proton discovered by the Rutherford, and the neutron is discovered by the Chadwick James. Now we will see the distribution of electrons. The distribution of electrons in atom is called as electronic configuration. Electrons are distributed according to their potential energies in different orbits. The different energy levels are known as the 1, 2, 3, 4 means first, second, third, fourth level. Okay, and corresponding shells are known as the KLMN. Okay, KLMN. These are the corresponding levels, corresponding shells. Sorry, so on, and the energy levels increases as the shell number, that is innermost K shell has the minimum energy and the outermost shell, okay, say suppose here N, so that has the higher energy. The maximum number of electrons present in a particular shell can be calculated by the formula 2n square. Okay, here n is what? Here n is orbit. For example, say we have to calculate the number of electrons in particular orbit. Say suppose K shell, in a K shell. Okay, so K shell, this is the first, okay, first orbit. So here n is equal to how much? N is equal to 1. So we can put this into this formula. So we will get the 2 multiplied by 1 square, which is equal to how much? That is 2. Means in a first orbit we have the 2 electrons. Likewise in a L, that is the second orbit, we have the 8. Okay, so here n will be 2, so 2 multiplied by 2 square. Okay, so that is equal to 8. And likewise in M shell 18 electrons are there. The last orbit, this one last orbit is known as the valence orbit, and the electron present in the last orbit is called as the valence electrons. Okay, the maximum number of electrons in the valence shell, last shell, okay, will be 8. Why? Because to stable the atom, right? The outermost imaginary orbit, the outermost imaginary orbit is known as the conduction shell or imaginary orbit or conduction band, and the gap between valence band valence band and the conduction band, this is the gap. Okay, so this is the gap, and this gap is known as the forbidden energy gap. Okay, forbidden energy gap. The electron near to nucleus are bounded by a strong covalent bond, and the electrons away from the nucleus are weakly bounded with the nucleus by a covalent bond. When an external force, we can say voltage, okay, voltage is given to the atom, then the covalent bond of the electron breaks down and electron will jump into the valence band. Means suppose this is the electron and we applied some voltage. Okay, so then this electron will jump into the valence band. Okay, and from the valence band it will jump into the conduction band. Okay, so the electron present in the conduction orbit called as a free electron. Now this is the conduction or conduction band, and the electron present in this, okay, that is a free electron or a movable electron or a mobile electron. So this was about the structure of atom. Thanks for watching.